So 2.3, today we're going to talk about polynomial functions of higher degree and modeling. Okay, so we're going to modeling and we're going to do modeling also. Okay, so let's do, first of all, talk about polynomial. A polynomial function is a function that is represented by something that looks like this. Okay, so this is what a polynomial function looks like. Okay, so each one of these little things is called a term. So you have terms, right? So you have terms, okay? And so in this one, you would have up to n terms, right? You don't have to have every single one, right? But you have up to, at the most, you would have n terms, okay? These a's here were called coefficients. These are called coefficients, okay? This is called the leading term, the leading coefficient, okay? So what else did they talk about there? Coefficient, leading term, term. Okay, this is also called the standard form of a polynomial. Okay. So let's see if we can do your work with this and see if we can do example number 1. Example number 1 says, describe how to transform the graph of an appropriate monomial function, f of x is equal to an to the x of n, an, so f of x is equal to an x to the nth power into the graph of a given function. Okay, so a is g of x is equal to 4x plus 1 cubed. So this one you would start with what? You would start with this guy, right? You would start with this guy and you would move it 1, right? Because you instead of x, you put x plus 1. So you move it 1 to the left or the right, right? Which one is it? Does anybody know?
The left.
It's the left, correct. It's the left, right? So I'm moving it 1. So I move this graph 1 to the left. Okay, all right, good. So that's A. And then let's talk about B. In B, we have h of x is equal to negative x minus 2 to the 4th plus 5. Okay, so on this one, we would start with x to negative y is equal to negative x to the 4th, right? Then I would move it, since instead of x, I put x minus 2, I'm moving it now 2 to the right, right? I'm going 2 to the right, so I'm going 2 to the right, and then I move this 5 over, I get y minus 5, right? So I'm going to move it 5 up, right? So I'm going to start with this guy, move it 2 to the right, and 5 up, okay? This is kind of review. We've already done this stuff, right? We already talked about transformation, so we're good. We should be okay with this. Okay, example number 2 says, graph the polynomial function located its extrema and zeros. Explain how it is related to the monomials from which it was built. Okay, so we have f of x is equal to x cubed plus x. And then we have g of x is equal to x cubed minus x. This is example number 2. Okay, and this one, so we're going to start this here is x cubed, okay? Now we're going to add the x to it, okay? And so what that ends up doing is it straightens it out a little bit here. Like that. So this would be this guy right here. Okay. This guy right here, again, you're going to start with x cubed. When you add the negative x to it, it looks like that. Okay, so again, a little, because you're adding negative x, right? Why is it with a negative x here? Okay, so it's going to have a little blip here, whereas you're going to add a x, right? Y is equal to x, you add that, so it's going to kind of curve it inside a little bit there. Okay. This is going to be x squared minus 1, x plus 1, x minus 1. So you're going to have minus 1, 0, and 1, right? So I'm going to have a local max here, a local min here. Over here, there are no local maxes or mins, okay? All right. Okay. So that's that. That looks good. Blah, 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 blah. Let's go to. So how do you actually draw a polynomial function? Well, let's go ahead and go to page 187. Middle, there's a blue box. Let's go ahead and read that first. Blue box says, a polynomial function of degree n has at most n minus 1 local extremas and at most n zeros. Okay, well, that makes sense, right? If you are an x cubed function, okay, you can only have 3 zeros, right? Up to 3 zeros, sometimes less, right? Okay, also, as we just showed you, there were 2 local extrema, okay, for an x cubed function. So there was n minus 1 amount of local extremas that you can have, okay, all right, which makes sense, okay? Now, let's move on to end behavior. End behavior, we're going to go ahead. In end behavior, you're looking at, if you had a function here, okay, I'm looking at, okay, this is x cubed again. I'm looking at the end behavior, meaning what happens when x goes all the way out to infinity in the positive direction or in the negative direction. Okay, that's what end behavior is. So you're looking at the end parts of the graph, okay, end parts of the graph. And in denoting that, so if this was f of x, okay, we denote that as saying limit as x goes to positive infinity, f of x, okay? So I'm sure this is the first time you guys are seeing the limits. So limit as x goes to infinity, I'm trying to find out what is happening to this function, okay? Limit as x goes to negative infinity would be the end behavior on that side. So this would be the left end behavior. This guy would be the right end behavior, right? Because this is the, I'm sorry, I got this. This would be the right end behavior. This guy would be the left end behavior, okay? All right. Because one's going to positive infinity, the right end. This is negative infinity going that way, so it is the left end. Okay? So flip the page, go to page 188. Page 188. Example number 3. Superimpose the graphs of that and x cubed and successively larger viewing windows. Okay, so we're calling it zooming out. What you're doing is you're taking a graph, okay, and if you looked at the one that they gave you, it looks like this. This is x cubed minus 4x squared minus 5x minus 3. Okay, so this guy here, okay, when you keep on zooming out, or the xy's, if you take the window from -10 to 10 and zoom it out to -100 to 100, okay, you're going to end up, this graph is going to end up looking like this, which is exactly what this graph looks like. Okay. What that really means is that this guy here is going to act like this guy in the grand scheme of things, in a larger picture. In other words, in this polynomial here, okay, this term here is going to dominate what the function looks like, because it looks exactly the same as this when I zoom it out. Okay, all right, that's what that means, okay? All right, so that's that. So how do you actually, so on the bottom of page 188, there's a large blue box. So take a gander at that. So go ahead and kind of read that through. Okay. If I have a polynomial of an even degree, okay, and the leading coefficient is positive, okay, the leading coefficient is positive, like this, okay. If I wanted to graph this, okay, if the leading coefficient is positive, I'm always going to start in this quadrant, up in this corner, okay. And I have fourth, this is fourth, that's going to look like this, okay. Where I have 1, 2, 3, 4. Okay. This does not mean that every quartic function or every x to the fourth power function is going to have 1, 2, 3, 4 solutions. Okay, it could have as many as 4, right? Because the graph can actually look like what? The graph can actually look like this, right? You can only have 2 solutions here. Okay. So again, if it's an even function, it starts here and it ends up here. If it's an odd function, all right, if it's an odd function, odd number polynomial degree, right? Then again, I start from here because it's positive, the leading coefficient is positive. Start here, 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. I start here, I'm going to end up here in an odd function, okay? When it was an even function, I started here, I ended up over here, okay? Now, if it's a negative, this is when it's positive, okay? When it's negative, right? Obviously, I'm going to have to flip that over, right? If it's negative, y is equal to negative, I don't know, 5x to the fourth plus 3x to the third minus x plus 1. It's negative, I'm going to start here. Okay, I'm going to, this is to the even function, so I'm going to end up over here. Like that. Okay? If it is a odd number up here instead of an even number, let's say y is equal to minus 3x to the fifth plus 4x squared plus 3x minus 1. Then I'm going to start again. I'm going to start here, but it's 5. So 1, 2, 3, 4, 5. Start here, end up over here. Okay? And that is what they have, what they're saying there in the blue box on the bottom of page 188. So go ahead and read that and see if it makes sense to you. Does everybody understand that now? We good?
Will our zeros be irrational numbers?
No, the zeros are just the x-intercepts, right?
Yeah.
Where do they go? Where do they meet with the x-intercept, with the x-axis?
So will it always be a whole number?
Nope. It can be any number, really. It can be a fraction. It can be a decimal. It could be square root of 2. I mean, there are all kinds of stuff, right? Okay, example number 4. Graph the polynomial in a window showing the extrema and zeros and its end behavior. Describe the end behavior using limits. Okay, so A is x cubed plus 2x squared minus 11x minus 12, and it looks like it graphs out like this. Okay, so if I want to go ahead and what does it say? So you're gonna have a local max here. You're gonna have a local min. So these are both local extrema, right? And then I have 1, 2, 3 x3 zeros. And the end behavior is as limit as x goes to infinity. I think this is f of x. F of x, as it goes over here, it's going to go up this way. So it's going to go to infinity. Limit as x goes to negative infinity of the f of x. So f of x, if I go to negative infinity, it's going to go all the way down there. Negative infinity. Okay. That was A. So we can do B here. B, I have g of x, 2x to the 4th, plus 2x cubed, minus 22x squared, minus 18x plus 35. This is x to the 4th, it's a positive, so it's going to start here. Looks like that. So again, limit as x goes to infinity, or infinity this way, it's going to go all the way up there. So g of x is equal to infinity. Limit as x goes to negative infinity, g of x. So x goes to negative infinity, it's going to go up that way. Also goes to infinity, right? Okay, we'll stop right there. And then when we come back, we'll do the finishes.
Mr. Ang,
Yes.
Ethan want to join us.
Oh, okay.